Hello there, this is Hans Forschner with Navcon Engineering. I put together this video on the changes to SoundPLAN Essential version 5. So I want to highlight some of the modifications from the previous version 4.0 and 4.1. There's a couple of new standards that are available in Essential version 5 that are related to the CNOSSOS standard in Europe. That's affecting road, railroad, and industrial noise modeling. So you can find that again in the settings under countries and settings. So there's CNOSSOS-EU for road, then you see CNOSSOS for rail, and then there's also CNOSSOS for industrial propagation. Then we have a couple changes in terms of developing DGM models, so digital ground models, and one of them is if you have a rail track in the model. Version 4 and 4.1 allowed you to consider the basically the elevation from roads and railroad tracks into the DGM calculation. Again, DGM for digital ground model. For rail now we have in addition some parameters. So here is the include road and rail edges. And now under the calculation settings we also have under the editor we can define actually we can define it right here. In terms of the DGM edges for the rail track is typically elevated, so we can define the track bed. So what is the total width of the track bed and how high is the actual track height above that track bed. So that will also allow you to be a little bit more specific in terms of the elevation along the track. Then in the road input and railroad input, we have now markers that allow you to set up bridges or define the beginning and the end of a bridge. And we also define the bridge width. So this assumes that the bridge or the road input is in the center of that bridge. So there will be probably some changes here for the TNM input. But for right now, this is the definition. So you can define where the bridge starts and where it ends, and you're defining a width. With that, the program will define a vertical plane under the road or under the railroad track. Half of the bridge width to the right and half of the bridge width to the left. And these edges will be used for screening calculation. And so if you have receivers that are below the bridge, the edges of the bridge will actually affect the propagation and will be shielded to those receivers that are below the bridge. Then we have additional inputs in terms of line or area sources that affect the input in terms of the the height of the source. So here we have now follow the terrain. So if we have follow the terrain selected, then the program in terms of an area source, it will look at the ground model or the triangles within the ground model and put the source height, in this case it's an area source, always 1.1 meter above the triangle. If you have a line source, it will put that line exactly, in this case 1.1 meter above the triangle. So with that you basically can ensure that the source is always above the ground triangles. If you imagine you have a situation where you have like a hill and you would basically, or some sort of embankment, and you had like two coordinates before and after that embankment, then if you have, for example, a line source, the line source would go right in through the embankment. with this follow terrain, this line source would go up the embankment and then drop down on the other side. So it would follow the triangles that define the embankment going up and going down on the other side. In terms of the input of point, line, and area sources, and there is now also some definition in terms of the correction value that we have right here. So here these corrections, so we have a little calculator here above that. This calculator allows us to define corrections or for basically the operation of the source. And so here we have whatever basic level or base level that we define for the source, and that could be again for line and areas per unit, which means it's a sound intensity either per line meter. We have here with per meter, so that's a sound intensity, or per unit, that would be the sound power for the entire source, the entire line, or the entire area. Now the time corrections gives us different options here in terms of events per hour. So here we could define specific events, so in terms of like a line input, and how often does this event happen in every hour of whatever time slice, or we can define it as the events per time slice. And then we have here again references as per minutes per hour or minutes per time slice. So again, hour is clear, it's 60 minutes, so that could be for like a Lmax hour. Or in terms of the minutes for a time slice for the daytime, for example, from 7 to 10 o'clock at night, or from 7 to 11 o'clock at night, or whatever time definition you selected. And then also here we have hours per time slice, so that could be, so we can say this source is on 5 hours out of the 15 hours, for example. So whatever selection you select, and then we put in the count. So if we had like here hours per time slice, and I put in 5 hours in a 15-hour time period, so I would get a correction of negative 4.8. So which is the logarithmic of 5 divided by 15, which is 1/3. The log of 1/3 times 10 is negative 4.8 decibels. So again, these are corrections that we can apply now, and then they will be automatically put into the time slices that we are calculating. In this case, day and night. Then we have, in terms of if you have like a single variant calculation up here in the settings, and the calculation is just for industry sources, then okay, yes, then SoundPLAN is now allows you to look at the mean propagation table. So in this calculation right now, I just selected to just see the point, line, and area sources. You can do a calculation. So let me do a single point calculation for these receivers. All right. And now if we go to the result tables, there is a mean propagation table. So this mean propagation table documents the average propagation parameters. So it basically defines your receiver, the source. So up here, with receiver, the source. Then we have day and night time. We have the average distance, average divergency effect. So that's the geometric spreading, average ground effect. Of course, depending on the standards, the ground effect may be frequency dependent. So this is again the average over all frequencies. The average barrier effect, the average atmospheric correction, and then whatever other averages that we have in here are basically documented. So here we have the basically the predicted level for that receiver, for that source, of 38.4 decibels. All right. So this is again only available if you have a single variant, and this is only available for point, line, and area sources. Of course, there are other result tables here. So here are the spectral information, and then here we have the contribution. So these again summarizing the contribution that are predicted, and then the individual prediction for the individual sources that are in the model. And then here we have the overall levels, and then related to whatever limits we have in this project. And then also the conflict, meaning that is how much we're exceeding whatever goals we have in terms of the noise levels. Then we have a couple of new shortcuts. If we're in the graphics, we can do a Control-C, and that will, it's a hotkey to basically save the graphic, and this will save the entire map, including the legend that is here on the right hand side. So here with Control-C we are getting this menu where we can define the resolution and so on. And there's another one, it's Control-Shift+C, and this basically will create a JPEG file without the legend. So we're basically just getting the contours or the graphics that we are seeing here in the center of the graphics. So again, here are some of the other maps with Shift, Control, and C. We are basically just getting this center map of that. All right, a few additional things in terms of the Essential project. If you save your Essential project and send it to a customer that has a full SoundPLAN version, SoundPLAN will now be able to load the Essential project as a situation, and it automatically will import the DGM separately from all the objects. And if you have any walls in the project, and the wall is calculated as a variant, then it will automatically have the wall in a separate geo file. So the import should be now pretty flawless into the full version of SoundPLAN. Now the last thing I want to discuss here is the import of OSM or OpenStreetMap data, and the way it works is kind of fairly easy. So the first thing you need to do is you need to start OpenStreetMap. So OpenStreetMap.org. So let me open that up. OpenStreetMap.org. And here I want to go to Los Angeles, California, and here I want to import a certain area into Essential. So I have an area selected right here. So let me zoom out, and I want to export that area. And here, kind of maybe important before you export it, you cannot just kind of have a huge area selected. There is a limit of, I think, 5,000 or 50,000, I'm not sure, elements that are in the OSM map. So the first thing I do here is I minimize the area that I'm exporting here. So I'm exporting an area around the freeway, the 405 freeway, right here. And so you can kind of see there's some housing, there's some roads in here, and I'll export that, and it will export the file into an OSM file, map OSM file. And what I found out is the OSM file can have roads, it can have elevation in it, but most of the time it's only a two-dimensional map. It has all the buildings, the location of the buildings. Sometimes it has paths. It's not only the major roads, but also paths, hike paths. So there's probably a lot of information that we don't necessarily need. and also parking lots and other areas. So we will see what we can import. So let me close this out. And I will create a new map, a new project, and I'll import, and as I say, OSM test import I45. And so here the first thing we need to set up, of course, would be the road inputs or the standards. I already have that set up as default. I define UTM Northern Hemisphere, and this is in zone 11. We go to editor, and at this point I want to import the buildings that we had in this OSM map. So I select buildings right here, and then we go file, import, and then we go OSM and buildings. Okay, and so here we have the OSM, and so it imported the OSM data. That's of course all of this is only two-dimensional, so there is no elevation, no height into that. The next thing I want to import is just the roads, so file. And actually we probably should import them as generic lines, but for right now I'll import them as roads, because that's kind of like maybe a little bit easier to kind of see what it's importing. And here we have the roads, and of course everything here has no elevation. So here you can see that it also imported a lot of the like hiking tracks, trails that we have here. So that's why I was kind of thinking of maybe importing it just as lines and then converting some of the lines back into roads. But for this point, for the this demo, I just wanted to kind of show you kind of the overall capabilities. Now, if we look at the 3D map, of course, this is only two-dimensional, so it's this area is actually pretty mountainous. So how do we get the rest into the model? So here we look at the Google Maps interface, which is a major development in version 5. So if I click on this icon here at the top right, this is the Google Maps icon. We can also go edit and connect to OSM and Google Maps. And it opens up a separate window, and it already knows where we should be. So here we have already the area that we imported through the OSM. And so what I'll do is I actually break down the area in smaller chunks. Actually, let me maybe do one first, right like this here. This gives us the overall view of the area that we imported. And I save map viewport, and I save it as 001, and this is I45 Moose. So this is kind of my total view. And if you look at that, so here we can kind of see what it imported. You see the roads, and the buildings right now are not shown, so we have to work on that in a second. And so next step, what we'll do is we go back in the OSM, and so we have that second window. I zoom in right in here, and I import the Google Maps elevation data, and it imports it, it filters it, and it triangulates it. So we go, I move that a little bit further up. I'll do another import. So here you can kind of see what it does, and I'll do a third import. Now this breaking it up in different areas of import is because when SoundPLAN imports the elevation data, it imports it basically 40 points in the vertical, south to north, and 80 points west to east. And if we zoom out too far, then the resolution is probably much bigger than the actual raw data that Google Earth provides in terms of elevation data. The elevation data provided by Google is based on a 70-meter grid. So by zooming in, we're getting a better, probably a closer elevation than, or enough elevation information to get more accurate information there. So now let's see. And so I think this is all I want to do with the interface. And so at this point, if we look at the 3D map, we will see here. So here you can see the elevation. So the terrain is morphed, or the aerial view is morphed over the terrain. That looks good. But we don't see the roads because they're actually below that, because the elevation of the road and the buildings is right below the aerial view. So if we go underground, you can kind of see where the actual buildings and the roads are. So we need to adjust that. So what we can do is, first of all, we change to the sitemap view. I select roads. I select all objects of current object type, and we use and change. We select objects onto the ground, or we set them onto the ground. All right, and then we select buildings, and we do the same thing. Select all the buildings, and we set the buildings onto the ground. All right. So now if we go to any buildings, you can see if I get the building, then I have a ground elevation for that building. All right. Now the building's heights, that's still something that needs to be updated and adjusted. But at least we now have the buildings on the ground. If we go into 3D view, we can now see more in detail where the buildings are relative to the ground and relative to the terrain. So this concludes the preview of version 5. And if you have any questions, please shoot me an email. You can reach me with my email, forschner@navcon.com. Have a nice day. Thank you.